Okay, so today we're going to solve some more equations. We love solving equations. This time, the equations that we're going to solve are multi-step equations, and they're going to have parentheses in there and other kind of stuff that make them a little bit more complicated. And by the time we get done with this lesson, we should be able to solve all kinds of different equations really well and be ready to be equation solving machines, okay? So, the first kind of equations that we're going to look at are equations where you have to use the distributive property because they've got parentheses in there. And we remember that when you see those parentheses with the 10 in the front, what we're really saying is that a plus 2 is getting multiplied by 10. So it's going to be 10 times a and 10 times 2. So our first step is going to be to use the distributive property to distribute that 10, and now it's going to be 5 plus 10a plus 20 because we did 10 times a to get 10a, and 10 times 2 to get 20. So hopefully you remember that distributive property idea and why the 10 times parentheses a plus 2 turns into 10a plus 20. It's because the whole a plus 2 is getting times by 10. So the a is getting times by 10 and the 2 is getting times by 10. Okay, I think we got it. Now, what the heck we have to do next to solve this equation? Well, what you'll notice is that we have a 5 and we have a 20, okay? And those 5 and 20 are like terms, so we can put them together and make 25. So it's really like the 10a plus 25 adds up to 35. And now we're just going to solve it like a normal two-step equation. Take 25 away from both sides. The 25's cancel out, and you just have 10a equals 35 minus 25, which is 10. And of course, at this point, you would divide both sides by 10, where 10 by 10 divided by 10 comes out to 1. I didn't write the divided by 10 on both sides, but I think you get the idea there. So, the distributive property is what we're going to use whenever we see parentheses. All right, let's try a couple more examples. How about this one? We've got 8, and then there's parentheses t plus 2. But on this one, there's a negative in front of the 8. Okay, so that minus 8 has to get distributed. It's not just 8 times t, it's minus 8 times t, so it's negative 8t. And it's not just 8 times 2, it's negative 8 times 2. So we're going to get negative 8t, and then we're going to get negative 16 here. Okay, now that we took care of that, we've got to look for anything that we can smush together. Like, for instance, 20t minus 8t. Those are like terms. And if you're not 100% sure on how to put those together correctly, I like to think of it as whatever kind of a word starts with a T. Like, if you have 20 tomatoes and you take away 8 tomatoes, you have 12 tomatoes, right? So I'm going to take that 20t minus 8t and I'm going to turn it into a 12t. Now, again, I got a normal, regular old two-step equation. I'm going to do plus 16 on both sides to cancel out the minus 16, and then I'll just have 12t on the left and negative 12 on the right. And I'm going to divide both sides by 12 to get t by itself. And when I do negative 12 divided by 12, I should get negative 1 as my solution to this equation. All right, so sometimes we have to use parentheses and the distributive property. Sometimes we've got to smush together like terms. And sometimes there are no parentheses. You just have to look for like terms right off the bat. So in this case, our first thing is we got 5a plus 10a. We've got 5 apples plus 10 apples. We're just going to say that's 15 apples, right? So we're going to simplify this whole equation by just combining the like terms together and making it shorter and sweeter. So 15a plus 5 equals 35, and then I cancel out the 5 so that I just have 15a on the left. 35 minus 5 is 30. Divide both sides by 15, and 30 divided by 15 comes out to 2. Okay, did that one make sense? I hope so. One more example problem, and I think then we'll be just about ready to go. This one's a little trickier because the B and the B aren't right next to each other, but hopefully you can see that you've got 5 bananas, and then you're going to take away 2 bananas, So 5 bananas minus 2 bananas is 3 bananas plus 11, because the plus 11 is just still there. Nothing happened with that. And the 50 is hanging out over there on the right by itself until we start canceling out this 11, and we're going to take 11 away from the 50. And now all we're going to have on the left side is 3b. And what we're going to have remaining on the right side is 50 minus 11, which is 39. And I'm going to divide both sides by 3 so that 3's cancel out. And I have just b left over on the left side. And I'll have my solution on the right side because 39 divided by 3 is 13. All right, so, I forgot on all these example problems, I wasn't plugging my answer back in. You've got to plug your answer back in to check to see if you did it correctly, right? But on a problem like this, I'm not just going to plug 13 in for that b, I've also got to plug 13 in for that b, don't I? So on these kind of more complex multi-step equations, plugging in your answer is a little bit more time consuming, but I think you could figure this out. So at the first part, 5 times 13 is 65 plus 11, so that's 76. And then you're going to take away 2 times 13, which is 26, so 76 minus 26. Oh, hey, that does come out to 50. Yippee! B does actually equal 13. We're 100% confident, super confident that we actually got this problem correct. We know for a fact that b equals 13, and we can move on feeling good about ourselves and our lives. And that's the beauty of solving equations. So how about you walk away from this equation feeling good about yourself by distributing, simplifying, solving, and then checking your answer to see what a actually equals. And then once you're done with that, you can try and, oh my goodness. I bet if you combine some like terms there, this probably isn't going to be as complicated as you think. So try to smush together the terms that are like terms, and then simplify this, and then solve it, and see what x comes out to. All right, we'll see how we did on these 2 practice problems in class tomorrow. Good luck, and see you next time.